Okay, here we are with Lesson 10. We're going to talk about volumes of familiar solids, cones, and cylinders. So go ahead and complete the opening exercise on the lesson worksheet, then continue the video when you are finished. Alright, you should be done with the opening exercise. For the opening exercise, write an equation to determine the volume of a rectangular prism. You should have come up with 48 times h millimeters cubed, because you weren't given a value for h, and so you could simplify the 8 times 6 to get 48. Here is part 2. Again, the volume would be 10 times 8, and then whatever the height is, it would be 80 times h inches cubed. For part 3, you would have the volume is the length times width times height. Again, 6 times 4 is 24, and you don't know what the h is, so it'd be 24h centimeters cubed. So write an equation for volume V in terms of the area of the base, which is B. Well, since you're given the base, 6 times 4, we know that is area, and if we're calling that B, then it would be base times height. Before we reveal the answer to part B, let's take a look at what we know about the formula of the volume of a rectangular prism. We will continue with an intuitive discussion of volume. The volume formula from the last lesson says that if the dimensions of a rectangular prism are length times width times height, then the volume of the rectangular prism is volume is equal to length times width times height. Referring to the picture, we call the blue rectangle at the bottom of the rectangular prism the base, and the length of any one of the edges perpendicular to the base the height of the rectangular prism. Then the formula says that V is equal to the area of the base times the height. Let's go ahead and take a look at this using some manipulatives. So right now what I have is the area of a rectangle. It is 3 inches by 5 inches. When I have that area is the length times the width, so I have area is 5 times 3, so the area is 15 inches squared. So now what happens is if I start adding cards to this, or height, because for every card that I add, this is going to increase the height. Even though this might be a very small amount, there is actually volume that is being created, because this is now a three-dimensional object. So as I keep adding more area, and this gets taller and taller, then what ends up happening is the height is going to affect the volume or dictate the volume. Since we're doing this in inches, and pretend that this is straight, then as I've added more index cards, I end up with a height. In this case, we're at 1/4 of an inch, pretending that if the 0 was at the very edge of the ruler. So as I keep adding cards, this creates the volume of the three-dimensional object, which is a rectangular prism if I talk about the stack. So whatever it is, 15 inches for the area, now if I have a height of 1/2 an inch, then I would multiply that by 15, and that would give me a volume. Alright, so examine the volume of a cylinder with a base B and a height of h. Is a solid, the example, the totality of all the line segments of length h lying above the plane so that each segment is perpendicular to the plane, and is its lower endpoint lying on the base as shown? So if you notice, you're given a very interesting figure. This could be a cylinder because basically we have a curved line. Actually, it doesn't make sense. A curved edge So this is still by definition a cylinder, and we have a point in the middle that attaches the top plane of the cylinder to the bottom plane of the cylinder. So do you know a name for the shape of this base? Well, there is no name, it's just some curvy shape. So let's examine another cylinder. This one is more familiar to you. We know the name of the shape of the base? Well, it appears to be a circle, so we will assume that it is a circle. So what do you notice about the line segments intersecting the base? The line segments appear to be perpendicular to the base. So what angle does a line segment appear to make with the base? The angle appears to be a right angle. When the base of a diagram is the shape of a circle and the line segments on the base are perpendicular to the base, then the shape of the diagram is called a right circular cylinder. We want to use a general formula for volume of a prism to apply this to the shape of a right circular cylinder. What is the general formula for finding the volume of a prism? Well, from before, you should know that volume is the area of the base times the height. So what is the area for the base of a right circular cylinder? Well, the area of a circle is equal to pi r squared. What information do we need to find the area of a circle? Well, we need to know the radius of the circle. What would be the volume of a right circular cylinder then? Well, the volume is equal to the base, which is pi r squared, times the height. So what information is needed to find the volume of a right circular cylinder? Well, we need to know the radius of the base and the height of the cylinder. All right, let's go ahead and take a look at another demonstration using a physical model of a circle. So again, I have the area of a circle that happens to have a radius of 1.25 or 1 1/4 centimeters. So again, if we know that information, then the area is pi r squared. So that would be pi times 1.25 squared. And when we square 1 and 25/100ths, we get 1.5625. And so our exact answer, if we leave it in terms of pi, is 1.625 pi centimeters squared. So the same thing happens. If this is our area, then as we do this, we add height to our area, then this is going to create our volume. So pretending that these are all completely flat, these discs, then as I add more of these discs, then I have a height that forms. Well, this height will then dictate the volume of the cylinder. So again, pretending that these are flat, right now I have added almost 1 centimeter in height. So it would be 1 centimeter times 1.5625 pi, and that would give me a volume of 1.625 pi cubic centimeters because I have 1 centimeter in height. If I continue to add to the height of my cylinder, then that increases my volume, and if this was again at the point of 0, this would be almost at 2.5 centimeters. So 2.5 centimeters times our area is going to give me the volume of this cylinder. Okay. So using what you learned in Part A, write an equation to determine the volume of the cylinder shown below. So you should have the volume is equal to base times the height, If the radius is 4 centimeters, which is indicated here, then that would be 4 squared times pi times h, which we don't know what the h is, but again, depending on how high our cylinder is, then that's going to determine the volume of our cylinder. All right, go ahead and try exercises 1 through 3 on your lesson worksheet. Continue the video when you are finished. All right, you should be done with exercises 1 through 3. So here are the answers. Again, if there's anything that doesn't make sense or a problem that doesn't come out correctly, please make a note and bring it to class. And on these, make sure you're showing the work. So as you come up with the answers, you should have work shown to this. Here are the answers to 2 and 3. And for part C. Next, we introduce the concept of a cone. We start with the general concept of a cylinder. So let P be a point in the plane that contains the top of a cylinder or height, which we'll call H. Then the totality of all the segments joining P to a point on the base is a solid called a cone, with a base B and a height of H. The point P is the top vertex of the cone. So here are some examples of a cone. Again, using our curvy shape, it doesn't matter that this is a curvy shape. This is still, by definition, a cylinder. So if we pick a point on the top part of that curvy shape, then as we radiate line segments from that, this creates a cone. And a more typical cone that you would see is if the point P is the center of the circle, then all points radiating to the edge of the base will give us a cone. So here are 2 examples of such cones. So let's examine the diagram on the right more closely. What is the shape of the base? Well, it again appears to be the shape of a circle. Where does the line segment from the vertex to the base appear to intersect the base? It appears to intersect at the center of the circle, so that's what we're talking about up here. What type of angle do the line segments and the base appear to make? Well, they appear to be at right angles. So if the vertex of a circular cone happens to lie on the line perpendicular to the circular base at its center, then the cone is called a right circular cone. We want to develop a general formula for the volume of a right circular cone from our general formula for cylinders. If we were to fill a cone of height h and a radius of r with rice or sand or water, how many cones do you think it would take to fill up a cylinder of the same height, h, and radius, r? So we have a demonstration that is actually a video. All right, go ahead and listen and watch.
In this video, we'll demonstrate the ratio of a volume of a cone and a volume of a cylinder. We have a cone and a cylinder with the same diameter and height. The cylinder is filled exactly with 3 full cones of water. The volume of the cone is 1/3 of the volume of the cylinder.
Okay, so now we know that when we have the volume of a cone we can find out a general formula for the volume of a right cone, or from the volume of a right cylinder. So, what do you think that's going to be? Well, since it took 3 cones to fill up a cylinder with the same dimensions, then the volume of the cone is 1/3 that of the cylinder. We know that the volume for a cylinder already, so the cone's volume will be 1/3 of the volume of a cylinder with the same base and same height. Therefore, the formula will be volume is equal to 1/3 times pi r squared times h. All right, now that we know that, go ahead and complete exercises 4 through 6. Continue the video when you are finished. All right, if you are done with exercises 4 through 6, then here are the answers. Again, making sure that you show your work and start by starting with the formula and then substituting the information that you know and then coming up with the answer. And here it is for 6. Again, if there's anything that you don't understand, go ahead and make a note of it and bring it to class. All right, let's wrap this up. We know the volume formulas for right circular cylinders, and we know the volume formula for the right circular cone with relation to right circular cylinder. And we can apply formulas for volume of right circular cylinders and cones. All right, we'll see you in class.